Assalamu alaikum wa rahmatullahi wa barakatuh. Alhamdulillah. My name is Khalid Muhammad Ariff from Sekitar Synergies near Berhad. I'm blessed to live until today, 4th of Rabiul Akhir 1442, 20th, yeah, 20th of November 2020. Thank you, YouTube. Thank you, all subscribers and viewers of this channel. Now, this video, we are going to look at a material which is quite common to all, which is solvent. I believe you're in one way or another, or maybe perhaps your industry is inundated with the use of solvent. So what are solvents? Solvents are as simple as water. Water is a solvent, but in this video we are going to look into chemical solvents actually, which is posing more hazard to us. We may be talking about, well, you may assume this sort of solvent that we are going to talk about is something like perhaps as simple as isopropyl alcohol, yeah, or probably methyl acetates, which is known as thinner, and maybe even benzene, toluene, naphthalene, etc. Now, solvent is a resource, and it is not cheap. So let's take a look how I would attempt this time to link a solvent recovery. This is more in the effort of renewable resources, recycling, extracting good solvent from what is contaminated solvent. This is the idea of solvent recovery. It's resource conservation. It is reducing resource depletion in the same way. Now, and at the same time, I will try to link safety, health, and environment and view them from one management system. Okay, so let's take a look. Okay, let's take a look at this solvent recovery unit that you're seeing before you. And this is physical technique in recovering solvents. So let's take a look at the link between health, safety, and environment from this particular activity. Now, let's take one environmental aspect, and we'll try to link the three. Let's take used solvent. Okay, and used solvent as an environmental aspect, I think you know used solvent might be coming from certain types of processes, probably in the manufacturing of ink or perhaps in the manufacturing of paint, where solvents like toluene, even naphthalene, benzene, or even xylene is being used commonly in the making of those products. Now, these work would generate, these processes would generate what is called spent solvent or used solvent. And by virtue of the fact that the chemical properties of solvent, as you already know, they are perhaps a benzene ring, a petrochemical derived chemical, and the fact that also most of this solvent is inflammable, if not, perhaps I would say some of them would be spontaneously combustible liquid, that is posing already a potential hazard at workplace. It can catch fire, or it can explode and cause some form of injury to human being and even fatality. So that is one association between potential hazard and potential risk. And the fact that this particular equipment is heavily powered with electrical energy, meaning there's a lot of electrical cable, higher voltage, electrical cable, and as you know, we are usually infested with rodents, uh, which could eat up some of the surface of the wire. This is seen in practice, and that could cause the wire to be bare, and human might handle it sometimes, and it would also perhaps some loose connectors, and accidents happen due to human error, and all this it would cause electrocution, and that would also lead to potential risk. And also the fact that this particular liquid used solvent, as I mentioned, it may come from different types of industrial processes involving different sets of chemicals, probably containing heavy metals and toxic metals and other hazardous material substances or matters. And this is used or solvent that is already hazardous liquid, especially when it is emitting volatile organics or volatile organic compounds into the air. And as you could see, it is partially confined area, and people are working that would cause health problems. And on top of that, there's a lot of heat involved, because this process is about heating hot plates in order to vaporize the used solvent, and the vapor is hot where the solvent is boiling at certain desired temperature, its physical properties, it is vaporizing and then condensed into usable or reusable solvent. And the remainder are the residues. So that process of heating is a lot of heat. This equipment is insulated, but workers has got to do maintenance, workers have got to do inspection while the unit is ongoing, and it's all about QC. So that would cause perhaps some kinds of intoxication, and also perhaps heat stress, and that would also lead to an environmental impact by virtue of all these injuries, accidents, and whereby medical attention is needed, is being deployed, all the medical equipments and medical stuffs are being wasted, and that will become an environmental impact as elsewhere, perhaps the medical incineration plant. Now, vice versa, the used solvent, as you know, is also posing from this reverse direction. That itself is posing health risk. Vapor, all right, intoxication. And when a worker is intoxicated or contaminated with this solvent, it may have some disorder in the nerve system, and maybe nausea, and perhaps some other ailments that render our friend not to be able to work according to the desired procedures of safety, and therefore the operational control from his work may be compromised and might lead to some form of accident, explosion, or fire. Then all these incidents will be a pose hazard, a risk to environment, and causing environmental impact, generation of fumes at a large scale, explosion, okay, and also maybe accidental release of volatile organics getting out of the building through its local exhaust ventilation, and due to some heavy vapors of solvent which is heavier than air, perhaps will go be suspended around the area and contaminate the surrounding environment. Could be a short term, could be a long term. Now, let's take a look at what we are here for, environmental management system. Please remember the definition of environmental management system. Now, I have before you three environmental aspects, which are SW501. In Malaysia, SW stands for scheduled waste. So one of the environmental aspects of interest from these units is the residue from the recovery. Okay, another environmental aspect is the output. After the solvent recovery, it becomes output, which is actually recovered solvent, another environmental aspect. And perhaps we'll discuss another environmental aspect of concern of the board of directors and chief executive officer perhaps of this particular industry, which is electrical energy. Why is it a concern? This particular equipment uses a lot of electrical energy and we got to pay for it. ROI, margins, okay, businesses. Now, these three environmental aspects is selected just for this discussion. Now, let's go back to the definition of environmental management system. You know by now that we have to manage all these environmental aspects, the three aspects that is before you now, and all other environmental aspects associated to this particular solvent recovery unit and the entire factory. We have to manage these environmental aspects. That is ISO 14001 version 2015, whereby the definition goes that we have to manage all these environmental aspects. How? By fulfilling compliance obligation. Compliance obligation could be not only the law, but also contracts, approval terms and conditions like EIA approval terms and conditions, written approval, written permission, permits, in short, by all the authorities. Okay, these are all legal binding approvals, and perhaps also your contracts with the supplier, vendors, clients. You may have an agreement with terms and conditions specifically stipulated therein. These are obligations, and perhaps we are renting the building from a landlord. There is another set of terms and conditions called tenancy agreement, or we are renting the land. Okay, and we may be interested well, an interested party to municipal building bylaws, okay, and perhaps other agencies, and perhaps even labor law, and perhaps even in this case, when we talk about potential hazards, insurance companies, okay, and governments, well, politics, not to talk about that anyway. So all these are interested parties which or who have got certain sets of interests upon us, and we have got to and that interest may be in the form of agreement, terms and conditions that we have got to comply. These are sets of what we call compliance obligation to manage these aspects, and then we have got to look for each aspect, or at least for this activity where the aspect originate or involved in terms of risk and opportunities. Are there any? So we'll discuss this. Now let's take a look. The first aspect that we are going to discuss is the SW501, which is the residue from the recovery units. I've explained that just now. It is using heat, and this residue is in the form of perhaps solid scales, like scales, you know. Now, we got to manage it, but do we understand how these residues are environmental aspects? Now, based on the definition of environmental aspect is anything, substance, matter, equipment, not process, anything that interact with or can interact with the environment. Let's take a look. And we got to look at clause 8 of this environmental management system, operational control, where when we want to do operational control, how to manage this environmental aspect, we got to look at it from its life cycle perspective. Therefore, let us begin. Residue is an output environmental aspect. So, what is its probable environmental impact is by looking downstream from its life cycle perspective. In other words, what happened to it? What happens next to this particular residue? So what happens next is, since it is scheduled waste in Malaysia, it will be collected, it will be managed as scheduled waste, labeled, documented, everything. And eventually, a contractor will collect this particular residue to a prescribed premise, perhaps incineration plant, perhaps a secure landfill premise. These are all licensed by the government. So what happens to this residue next? It will be transported from your factory, from this factory, to that premise, and if it is being burnt in that premise, this is the interaction. If it is being burnt in that premise incinerator, what will happen? It will cause an interaction with the environment in the incinerator, releasing air impurities and causing air pollution. That is the associated impact to this aspect. Or and this incinerator may be coupled with air pollution control equipment, perhaps a scrubber, just example. And that scrubber has got what? Scrubber liquid. And that liquid, after scrubbing, has got to be released due to burning our residue, and it is trapped in the scrubber. Cleaner air comes out of the stack of the incinerator. The scrubber water is recycled to a certain point of saturation that it cannot scrub anymore, or is too thick and even kaput all the transfer pump, etc. Then those recycled scrubber water has got to be treated in an industrial effluent treatment system, where after treatment the cleaner water will be released to the river or perhaps monsoon rain and causes water pollution. And that is another subsequent interaction to the environment. And if this residue doesn't go to the incinerator, it may be transported to what is called a secure landfill. Heard of it, right? And that secure landfill, as you know, there is always leachate, we call it. And that leach may find its way into the ground one way or another. The earth is moving. No secure landfill is absolute secure. Those civil structure can give way after time. Then it will enter the soil and causes soil pollution, all right, and also get into groundwater and cause groundwater contamination. That is the interaction, the subsequent chain of events whereby this particular residue interacts with the environment and causes environmental impact as explained, and the whole thing from the residue to the environmental impact is only its downstream life cycle. Got it? Okay. Let's take a look at the next one, which is recovered solvent. Okay, let's take a look at recovered solvent. As you could see now, there is this code SW322, which is spent solvent based on environmental law in Malaysia, called Schedule Waste Regulation 2005. Now, look, this particular law, despite the fact that this solvent is recovered, it is still schedule waste. If this solvent is being disposed of, it is still schedule waste. If this solvent re-enter the plant as a renewed resource, ironically, this law says it is still scheduled waste. So it's the management of scheduled waste apparently is from cradle to cradle. Got it? Now, this is a recovered solvent whereby it is produced from the condensate from this particular solvent recovery unit. Remember, the solvent is heated up, it gets into vapor at high temperature, and it is condensed into recovered solvent. And it is being reused by this factory. So, what happened? It is still an environmental aspect, right? How is it an environmental aspect? Then what would be the environmental impact? Since recovered solvent is the output of this environmental aspect, okay, the output of this recovery, and looking at its upstream life cycle perspective, it comes from the solvent recovery unit, right? And when there is more recovered solvent is being generated, less fresh solvent is needed for this factory, for the process before this. And therefore, as it enters as a renewed solvent, the demand for fresh solvent is less. The interaction to the environment in the production of fresh solvent is nil. Therefore, recovery of this solvent will lead to a less demand for fresh solvents, less demand from, it comes from oil and gas, less demand for crude oil, and less extraction of fossil fuel. In that manner, we are able to conserve resources. That is the green environmental impact, which is doing a favor for environmental resources, less demand for fossil fuel. Fossil fuel is a limited inventory, and the more demand for fossil fuel, the more depletion rate, and at the same time, less drilling, less tampering, less damaging to the geological structure, and we are able to at least retard or slow down the drilling of oil, and therefore we are able to conserve geological structures, less damage. That is the plus point of recovered solvent as an output from this particular facility. Okay, if I've gone wrong somewhere, please correct me. It can be confusing in a way if you've been dealing with this. Can you imagine if we do aspects, impact, an array of environmental aspects that you got to list down? So you got to be careful when you do input output analysis. Now, electrical energy here is a lot, and electrical energy comes into this process as input. Power coming from what? That's the interaction with the environment. It is an input. Therefore, it is an input aspect. Therefore, we look at its upstream of the life cycle perspective. What happened? The more demand for electrical energy, in this case, in this country, there's a lot of coal-fired power plant because diesel and gas is getting so expensive. Well, before the COVID, now it is a bit less, but still maintain at certain level of price. Now, when there is more demand for electrical energy, this is the interaction and rendering it an environmental aspect. When there is more demand for fossil fuel, which is coal. And it comes, and this energy comes from a coal-fired power plant, as I've discussed in earlier videos. So the more mining of coal, and when there is more mining of coal, what happened to coal reserve in our earth? it becomes less. So that would cause a state of an environmental impact popularly known as resource depletion. Those coal resources is getting less and less. Ironically, more people die in coal mining operation as compared to nuclear plants. Correct me if I'm wrong. Now, and when you've got to blast the rock structure and mine the coal out of some bedrock, some are very deep. You have even deep shaft coal mining, and these are causing damage to the bedrock, and some of these mines even collapse. You have seen and heard it from news. All right, these are geological structures that you and me tampered with in order to get fossil fuel, and for that reason we got to look at the risk and opportunity when we are managing all this environmental aspect via this solvent recovery unit. So what is the risk associated? Let's take a look. The first risk that we're going to talk about is legal liability. Namely, in this country, for this particular environmental aspects like SW501 residues and SW322, the legal liability over here is pertaining to the Schedule Waste Law. And there are other legal liability. Perhaps there is some limits of usage of electrical energy for this unit from the source of energy body itself, the corporate company that own electrical energy in this country. We can use to a maximum. Some of these industries are regulated to use to a maximum level of energy input, not more. And more means higher tariff. Those are other legal liabilities that we can look at, and it is related to the energy consumption. When I state energy consumption here, I'm not referring to the corporate company that produces the electrical energy. I'm more concerned of that check that your chartered accountant, the CEO, has got to sign to pay for this bills, electrical bills for the company. Is a lot of money involved, despite the fact that you're able to save some solvent, which is recovered, but there's a lot of money involved for the high level of electrical power. Those are risks to businesses. Business first or environment first? Get back to 1992, the first Earth Summit, Rio de Janeiro. There is a report called Brundtland Report. Take a look and come back in the comments if you found it. Now, another risk is regards to the fugitive volatile organic carbons. It is the fumes from the solvent prior recovery and even during recovery. During this recovery, those fumes are trapped and condensed, okay? And they got scales. Literally, there's no exhaust out from these recovery units. But this fugitive volatile organic carbon is from the handling of the solvent prior to recovery. It could be some leakage, or even in the factory when they're handling the solvent. What shall we do about it? And there are some emissions from this recovery unit as well, from the storage of the solvent around it. Or maybe when there is excess pressure, they may have relief valve, and that would be fugitive release of volatile organic compounds. So what shall we use? Opportunity. What is the available opportunity before us for this particular system? Scrubber? Oh, that's a genius. Let's use scrubber so that we can scrub the gas stream and trap this vapors of solvent, the volatile organic compound. Acid weight. if you deploy a wet scrubber, you're going to have eventually what? Waste water from the scrubber units. You got to replace it. It gets saturated. You got to replace the scrubber water. And where are we going to dispose the contaminated or saturated scrubber water? Into the drain? It has got to comply with the Malaysian law. Effluent. Okay, and for that you got to build yourself an industrial effluent treatment system. More money for the company, right? Think about it. And there you are. For the existence of scrubber, you need to have wastewater treatment plant. Okay, so I believe that that might not be the case, and I would suggest off the record, if there is any emission, there are emissions actually from the local exhaust or from the exhaust of this particular recovery unit. And also we can install hoods around the area to minimize the concentration of fugitive volatile organic carbon in the area itself. We can use adsorbent material. I've done it. Okay, we extract those exhausts through a column of adsorbent. What is the best adsorbent for volatile organic carbons? Some of you know this. Those who have attended my training before this have done it. Okay, I think you know about activated carbon. It's made from, well, plants, shells of coconuts, even kernels of palm oil, and even bamboo. It's not about what it's made from, it's how to make it. Okay, so maybe we can use it as an adsorbent. It is able to absorb all this volatile organic carbon and prevent ourselves from building a scrubber, which would eventually lead to the need to build another system, which is wastewater treatment plants. Okay, and also we can look into this. This is what I am here for. You have seen my logo, right? This is why I make this video. I didn't have the luxury to do it, but I am banking on the brains of younger people and experienced people now in this world to do this. However, we put aside politics, so in many ways would have some impetus or block the impetus of this endeavor, but so I won't talk about it anyway. So renewable energy resource is we can have our own perhaps wind turbine or solar panel. Now there are upgraded versions of solar panel. A small unit can produce the same amount of power as the bigger units. And these are all amounting to research. And I hope universities will play a part here and develop something new. Okay, and I believe our brains can churn something out of it and make use of renewable energy resource. We've got water, we've got solar, we've got air. These are all environmental media that can be turned into power and be used in this particular equipment. That is the opportunity and risk that we have got to identify, comprehend, and try to come up with intended outcome for our activity as per requirement of the environmental management system ISO 14001. And once we have got our intended outcome, we find ways to achieve, we plan how to achieve those intended outcomes, and we may come up with our sets of objectives and targets and program. Doesn't matter. The entire thing is called planning actions to achieve. We can call it EMP, nothing wrong. We can call it objective and targets. Those are sub-elements of the entire bigger element, which is planning actions to achieve what? Intended outcome. Intended outcome, top management, you decide. Got it? That is Environmental Management System ISO 14001 version 2015. So it's been a mouthful talking about this. I hope I didn't put you to sleep. Lectures, okay? But this is the best I could do. Please, SHO experts, industrial hygienists, industrial chemists, chemical engineers, mechanical engineers, electrical energy engineers, civil engineers, ecologists, biologists, say something. I intend to help people who didn't have the luxury, who doesn't have the luxury for education. So let them share what we have here, and I hope you would contribute in this. So thank you, YouTube. YouTube, you are amazing in providing this, and hopefully the internet sustain. And I thank you all subscribers, viewers, and all for this channel. Do support me by subscribing if your conscience is clear. I wish everybody in Bahasa Melayu, where I'm from, Malaysia, you can get somebody to translate it for you. This is how it goes. Semoga dikurniakan kesenangan, keselamatan, kesejahteraan, kebahagiaan, dan kejayaan kehidupan you all di dunia dan di akhirat. And I end this video by wishing everybody, wherever you are, whatever skin color, whatever age, whatever gender, and whatever faith have you, with this wish, until we meet in the next video, inshallah, I wish all of you Assalamu alaikum wa rahmatullahi wa barakatuh.